Active Management, co-founder, COO, and Open EBS, Litmus, Cloud Native, Kubernetes are some of his area of interest. With that, I would like to hand over to Uma. Can you hear us?
Yes, can you?
Yes.
All right, thanks, Savita, for a nice introduction. Said too many things about me. It's nice being here. Thank you guys for accepting my talk. I would love to share some thoughts on how can you be better off running Kubernetes if you have chosen to go with it, right? And which probably is the right thing, good decision. So I'll probably take about 20-25 minutes, and then if there is more time or questions we can take. If not, I can just walk you guys through some demo. So let's talk a little bit about me and where do I work. Yes, I do love building teams. That's my role as well as a COO. But it's MayaData is about building technologies in open source. We started this company about 4 years ago now. We have created. We operate purely on Kubernetes space, right? All our solutions are about solving problems for SREs on Kubernetes, right? Or developers on Kubernetes. I have, in the last few years, I've co-created 2 open source projects, OpenEBS, which is a cloud native data management project, and it's in CNCF sandbox. And the other project that we started 2 years ago is Litmus, which is cloud native chaos engineering project. And Kubera is a commercial version for cloud native data management, the OpenEBS side of stuff. And it's about using Kubernetes for the problems that it does not solve right away, which is data management. And then in this talk, we're going to talk about chaos engineering and how you can solve some of the problems that you may be facing, right? So that's about it. So I work out of Bangalore. I would have loved to meet all of you guys. Last year, I met some of you at OSCon, but it's great to be here again. All right, so what we're going to talk is I want to touch upon what is the state of Kubernetes. Everyone is using it. If they are open source lovers, that's great, but what is the real status and what could be some of the problems? That's what we talk about in the beginning, and then let's see if those apply to Kubernetes upgrades. And GitOps is a very commonly used topic, and my talk is also about using GitOps and chaos engineering together to get a little bit more freedom of life when you're using Kubernetes, right? So how do we do that? And then we'll talk about what are the CNCF projects in that area, and you can take a look at in more detail if you like. So that's the agenda. So first, state of Kubernetes, right? So that's great news. We crossed chasm as Kubernetes adopters. It's graduated a couple of years ago. Most of the IT environments have plans to move to Kubernetes, and or they're already in the process of moving or already moved and they're operating, right? So there are, but definitely it has crossed a chasm, right? So is that good enough? No, obviously. The CNCF itself is a foundation where there are more projects to get this Kubernetes adoption done, right? It is centered around Kubernetes, and more solutions are coming out, cloud native projects, Kubernetes being the bigger one. And one of the things that is needed at this time, I mean, there are a lot of things that get done in CNCF ecosystem. One of the things that I'm going to talk here is you have chosen to go with Kubernetes. How are you managing it, right? So is it the same old way, or Kubernetes is about being new, right? So you want to get things done in a better way, and all the cloud service providers that are giving Kubernetes, they cannot give a different API. It is Kubernetes API. You write once, you can run it anywhere, and you don't have a lock-in, all that stuff, right? So operations is still a big deal, right? It will always be a big deal. Many of you know that there is service that will always go down at some point, right? So the question is, how rarely it goes down, rather, will it ever go down? That's never the question, right? So one thing that I think, and many SREs think, in my opinion, is it's a chaos first principle, right? I'm going to go and make our customers, developers life easy. So we're choosing Kubernetes. So let's go with chaos first principle, right? So chaos and resilience are like opposite directions, but both are needed, right? You have a lot of chaos. That means there's no resilience on your Kubernetes. And we are going to talk about you need chaos in order to get resilience, right? So you introduce chaos, that's the idea, right? So Kubernetes right now needs, SREs right now need process and tools to go on with the chaos first principle, right? And where do we apply this chaos? In a lot of places. In this talk, we are just going to talk about in the process of Kubernetes upgrades, right? And before and after, all that stuff, right? So you need to have a process to keep your resilience high. What is resilience, right? It's very simple. Resilience is the system's ability to stay afloat whenever there's a fault that happens. And then, some of the examples could be, how many people know that there was a problem with my application when some pods are evicted? Why they were evicted? Well, like Kubernetes can run them anywhere depending on various conditions and all that stuff. Your service has to be resilient for such things. This is not even a chaos. It is very, very normal, right? So pod getting evicted and nodes going to not ready is also pretty common. Kubernetes is stable, but the service providers, I have a demo today that I do. I'm not sure. It could go into a not ready state. So I'm just praying God that, hey, don't give that. So, but I have to make my demo more resilient, right? So it's all about being resilient, right? So it could, your services can go down if many nodes go into not ready state. You still have to be resilient. You have to put them, your service, make them available across zones, all that stuff, right? And you have so many containers, a CPU hog or memory leak can happen anywhere. So we are talking about the basic failures that could happen, and then there are lots and lots of other types of failures that could happen. So you have to be resilient to all these types of faults. Not being resilient is a sign of weakness, right? So so that's needed, right? So if that is, why is it this resilience so important in cloud native environment, right? Cloud native environment or CNCF landscape is ever growing. They have many tabs, as you can see. It's getting smaller and smaller each image, because there's more, everybody's embracing the tech around here, right? And because Kubernetes microservices, one thing that's becoming stronger is their ability to deliver things fast, right? The purpose of Kubernetes is left shift and go fast, right? So databases are also coming faster. Your application changes are coming faster. So if you are adopting cloud native technologies, what you are seeing is that there are so many things that keep changing, right? It is not that I do application upgrade, I deploy an application and upgrade happens once in a quarter or 6 months or a year. That's not the case now. If you're doing every 3 months a particular service, if it is now on Kubernetes, the changes may be coming much faster because they're also on microservices, right? So the purpose of moving to Kubernetes is to um, drive your releases much faster, right? So that's dynamism. That's one thing that changes this resilience, right? So you are running a service. What is your resilience matrix, right? So of course, resilience of your service, however smart you are, however stable your service is, it really depends on the underlying Kubernetes service, right? So that's the platform, right? And then the Kubernetes itself, if you're running on any one of this cloud services, master node is not in your control also. Of course, they say that, yeah, it's for good, but you depend on that, right? And as I said, there are so many other cloud native projects that you tend to use: Prometheus, CodeDNS, Envoy, and so many other databases that are part of your deployment. This is the stack that you depend for your application to be resilient. It's not just enough that your application will run fine, your service will run fine if it is well tested, but you have to assume that everybody else also can have some issues. And will they, if a fault happens in MongoDB, will MongoDB recover and not cause any trouble to me? And even if it causes any trouble, am I resilient enough to sustain that fault and go there? So it can percolate all the way down to the physical infrastructure, right? So the summary is that if you're wanting to put your SLOs, right, service level objectives, on your service, you have to take care of the services resilience all the way down, right? So 90% of your resilience depends on other applications, not your application. Again, one of the reasons, hey, I moved out from this cloud to that cloud. Yeah, Kubernetes doesn't run, or that service doesn't work properly. So that's one of the things that we hear, but it's not just Kubernetes. There are other things that are in the Kubernetes ecosystem. So what we are trying to say here is that there are too many microservices that you're seeing apart from your own effort to move to Kubernetes, and the changes are happening very, very fast, right? So, and as you scale your service on Kubernetes, you tend to get more and more applications into your system. You have to automate this process of checking the resilience, right? So we've been saying, yeah, automation testing, right? So it's not just simple testing, it's about resilience testing, right? So that's what is needed. And typically we have been saying the testing is limited to, yeah, pre-prod, and then I just move it up into production, I'm done, right? So that's old way of saying. Chaos first principle for SREs is really about yeah, I will do the testing one all the time, right? So that's chaos engineering, right? And how does this apply to Kubernetes upgrades, right? So this resilience is before even you actually upgrade Kubernetes, you have to have a pipeline for verification, and verification we'll talk a little bit about that soon. But it doesn't stop there, right? You have to, even after the upgrade, you have to be able to continuously tune, because you will never have the same um, ecosystem or staging environment that is there in your production, right? You can be very good, you can invest a lot of effort and resources to keep your staging pre-prod environment as close to as production, but it will never be the same. So if you say that I've done all my testing before upgrade, I've automated everything, so I'm good, it should work. Well, at some point it may not. So what you have to do is you have to have a similar or even larger pipeline to continue doing resilience testing in your production after the upgrade, right? So keep checking if something is breaking, right? So before upgrade, you add chaos tests, right? Chaos tests to your pipeline, right? Chaos tests for Kubernetes itself, right? I'm moving to 1.x version from 1.y. So what is the difference? So can I actually test if Kubernetes works fine, right? That's functionality. I mean, chaos test in this case, what I'm saying is, let's see if Kubernetes fails something and my applications work fine or not, right? An example of that is a pod gets deleted, right? And a node goes into bad state. What happens to my services? That's the pipeline before upgrade. Similarly, you need to add more tests about if you're using any other cloud native technologies, you add chaos tests for that as well. What happens if Prometheus database is full, right? So that's a test that you need to do, right? And that scenario may be working well in Kubernetes 1.15, but it may not be working well in 1.16. Who knows, right? So that's something like that you test. Similarly, the new thing that I'm at least advocating here is take those chaos tests and then push them after upgrade also, right? So this is where a lot of people get scared. SREs are at least trying to get used to the principle of chaos first in many organizations, and they're advocating chaos engineering is becoming a common practice, but it has to start also at developers, right? So they should expect that don't assume that my code will not be hit. um, Something else will go fine, go wrong, because these SREs are going to break it anyway, right? So they don't wait. The moment I push my code to upgrade and push into production, they upgrade it and they start breaking down all the stuff. So I might have a weakness in my code. It's not resilient enough. So you have to start testing that at a developer level itself, right? So in production, you have to start advocating use of chaos tests for Kubernetes as well as for cloud native technologies, right? So what is a chaos test? We talked about what is resilient, right? Resilience. Chaos test is to check if your service is resilient, right? How do I check? Just introduce the fault. Don't wait for the fault to happen. You do it yourself, right? And how do I do that? It's the fundamental block of chaos engineering. And identify the steady state for your service, which could be a total different thing for different people at different times, but you know what is the steady state for your service mean, right? And then introduce a fault, and then check if after the fault is injected, if your service is regained that steady state. If yes, it's your service is resilient. If not, you have found a weakness. Good, go fix it, right? So no need to call everybody in the company and burn their hands. You have introduced this fault at the right time, a minimal fault to test, and then go and uh, fix that weakness, and people will actually appreciate that you found a weakness, right? If the fault happens naturally, then you will be taking the heat in a reverse way. How come you are not having your operations in a resilient manner? You should have found this weakness, right? So you can turn those opportunities into where you have better teamwork going on, and then everybody is always about introducing faults, finding weaknesses. In the initial days, your service may be going down here, there, in some manner, but over a period of time, you become ultra resilient, right? So you got all the answers that you want, right? So that's chaos engineering, how to do it cloud native way, right? So we're talking about Kubernetes upgrades needing chaos tests before and after. What is a chaos test? And now we're talking about how do you do them in a cloud native way, right? So one answer is make them fully automated, right? So not just the other parts, right? We talked about a lot of Terraform and automation here in this conference as well, but operations need to be automated, and operations now have chaos first as a principle, right? So we will see what is that first one, right? So resilience checks need to be fully automated. So fully automation, having fully automate things is the real key here, right? So how do you do use GitOps? It's being practiced by the new age SREs. So what is GitOps, right? So GitOps is using Git not just for your code, but for your operations, right? So put your YAML that you have, the manifest, in in Git and take it through your regular version control process, and then on your Kubernetes cluster, deploy technologies like Flux or Go CD, who actually keep looking at for any changes for this configuration that is there in Git, and it gets deployed, right? So the configuration gets reapplied whenever there is a change. So why is it so important for an operation, right? So let's say something you upgraded, something goes wrong, you can revert back very, very quick, right? So send a PR or revert that PR, and then you can regain all your services. The big change that you enrolled, you can put it back very, very quickly, right? So that's GitOps for operations. Now we are talking about, well, GitOps is about automatically deploying and reversing. What we are saying is use GitOps for continuously introducing faults as well, right? So this chaos tests are also a big deal, right? So what kind of failure tests that you do, that also need to be managed in production, right? So that needs to be approved. And how will you're going to take a service down, right, in one area or a node down, and it's not that simple. Management has to be involved, and the proper DevOps clearances need to be done. And first of all, you have to get approval for doing chaos engineering. Now you did, and you actually have to do, and in a random way. So this week I'm going to kill one node at a random time. I don't know when I'm going to kill, but in definitely in this week. Shall I go ahead? Yes. Send a PR to that config for the chaos test, and that gets deployed. And somewhere within this week, you're going to go see one node going down, something like that, right? So it's very important you apply this principle of GitOps to manage your configuration for your chaos test, right? So you run this Kubernetes specific chaos test as well as cloud native tests using GitOps, right? So how do I get this chaos test? So that's the next one, right? I think I have about 15 more minutes. So let me run through this chaos test itself, right? We have told that resilience is important, chaos testing is important, and how you automate it is using GitOps. And now, what about chaos test itself, right? So the KI test. So that's where we introduce Litmus. Litmus is a complete framework for doing chaos engineering on Kubernetes and to find weaknesses. So who uses it? SR is used to do chaos engineering in production, pre-production, and developers use them in to do failure testing in the pipelines itself, right? So that's what Litmus is about. It provides an infrastructure to conceptualize a testing, chaos testing, and actually execute and monitor and then manage, bring out intuitions, and it helps you really find a weakness. And then, of course, it doesn't fix it automatically, but it tells, what's your weakness, right? So once you find a weakness, you know how exactly to go about it, right? So, and it is a CNCF project. We recently got into Sandbox. These are the links that you can take a look at it. It's 100% open source, driven completely community model. Our mission statement, as I just said, is about finding weaknesses, make your systems more resilient. And we are the prime maintainers, MayaData. We have also got maintainers from well-reputed organizations like Intervate, Amazon, RingCentral, Container Solutions. Chaos is a need for everyone, so there is more and more traction, and then people are contributing back, right? So take a look at the hub. Just like Helm Hub, you will start seeing more and more chaos charts getting into hub. Yeah, Litmus Chaos Hub. And if you want to go introduce some failure, go and find an experiment, pick an experiment, and then just run it, and you might find one, right? So we are growing pretty well. Last few months, we have reached, I think, July 17th, 66K experiments. Today, I just checked, it's about closer to 77. So people are picking up things fast. About 1,000 to 1,500 experiments are being run on a daily basis. Who knows? It may be double in the next few weeks itself. So it's really heartening to see community has picked it up. Right. So the features it has is complete declarative API for introducing chaos. Right. And you have the hub, ready experiments, and you have the SDK to write your own experiments in Go, Python, and Ansible. You don't need to learn a lot of stuff about how Litmus works. Just use the SDK, create a new experiment, go actually put your Go code about what you want to kill and observe after and before killing, right? So Portal is it's not just about experiment, but there are more complex workflows that you need to do. You found weaknesses in the last couple of months, but what now? No, I want to find even more weaknesses that may be rare, but I need to go about it. So you need a chaos workflow, a combination of multiple faults that can happen, right? So Litmus gives you not only just a framework, it gives you a lot of ready-to-use experiments, and they are growing. We are about 30 to 35 experiments right now. Many are in the making, community is contributing. So you will have a lot of platform chaos, Kubernetes chaos. Recently, we added a kubelet service scale, right? Which is pretty common to have. I mean, pretty common means not in an everyday basis, but you're running everything, but kubelet service can go down, right? So then the blast radius can be like unusually high. So you need to take care of recovering from that situation. So why not kill that kubelet service yourself? Use this experiment, and then it becomes a few minutes job to reproduce that scenario, right? And that's Kubernetes chaos. But there are so many other things that you've been using on Kubernetes. So what if they go down in some form or other, right? So you need to have experiments. So our experiments on the application specific side keeps going up. And where can you use this, right? We talked about the Kubernetes upgrade, but really it's about you can use them everywhere in the DevOps cycle, but you generally start small, right? So DevOps CI pipeline may not have like hundreds of test cases that you need to test there because the scenarios itself is small. But as you move towards production, the number of tests that you can, number of scenarios you can consider to break can be very, very high. You may be doing like in a staggered fashion, but well, I've done 5 types of failures. My production seems to be resilient. Let me try one more next week, right? So you keep adding more and more and more chaos tests to that. And let's revisit. Okay, now we understood chaos is needed, and Litmus is there to introduce chaos and readily available. And how do I automate it, right? So that's what is the next step to understand, right? So what you do is, because it's all declarative API, you put all your entire chaos experiment into YAML spec, and then you attach a scheduler, and you put that into a big YAML spec and put it into Git, right? And then you configure Argo CDR Flux, and then your chaos is running, right? So we have something called Litmus demo. It's a pre-packaged Kubernetes script or application. You can actually get start with chaos, and then within 5 minutes, you will be able to kill a pod in a very automated way. It's so easy, right? Um, that is for one experiment. But what about a scenario, right? It's not just about killing a pod. You want to say that, hey, when some network went down or it became slow, and then this pod was evicted, it moved there, and then there was a CPU hog on the other side, or CPU was very, very less. 90% of the system, that node was running on a 90% CPU. And then under that scenario, some problem can happen or happened, right? You want to reintroduce that kind of a test, right? And you can do that, right? So you need to stitch multiple applications together, multiple chaos experiments together in a serial parallel combination. And you write each of the experiment into a separate YAML spec, and then you create a chaos workflow. A chaos workflow is nothing but a complex fail path scenario, right? So when all when everything can go wrong, imagine what all can go wrong, right? You put that into a complex chaos and then try to do that yourself. So that's chaos workflow, right? So how do you do that? You use Argo, right? So you have Litmus to do the basic testing and I mean complex testing as well, but it's about orchestrating chaos, right? But you need to orchestrate the chaos experiments together in a workflow manner. You can use Argo, right? Argo workflow is another thing where you put all those experiments into an Argo workflow and make it again the same model, put them into Git, and Argo CD will, Argo has two parts, Argo workflow and Argo CD. Here we are telling both, right? Use Argo CD to pull the configuration that is there in the Git and deploy. And when you deploy, it is an Argo workflow. That means, it has got 10 things to do, and those 10 things, each of them is a chaos job, right? So chaos experiment. So now you have multiple chaos experiments running the way you want. Sometimes this workflow can go for a long, long time because you run this and then wait for a week, wait for a few days, and then do this and then see what happens, right? It depends. So just to summarize, now we are talking introduce before your Kubernetes upgrade chaos test, use GitOps, and same way after your upgrade also use chaos test both for Kubernetes and cloud native applications, right? So this is an example of how your Argo workflow will happen after Kubernetes upgrade. I picked it up from one of the scenarios. You have a lot of backend tests, right? It's a pipeline. Everything is running fine, and then I go and run a couple of tests there. Everything is working fine. Now I go introduce some chaos, and introduced a simple into an order state, orders application, while introduce some more traffic into the orders application, introduce chaos, and after that you go and introduce the same chaos into a database and see if everything is fine, right? And then you revert the chaos, whatever is introduced, and then see if everything happens. So that's how you can consider. And also, I'll just show a real world example of how I've been using. I'm running on EKS a couple of applications. This application is a microservices example, microservices demo example called Sock Shop, and it's running fine. But I have a workflow that keeps killing or at least doing some CPU hog, memory hog, and I have two application workflows. One application specific, and the other one is Kubernetes specific. And I can actually go and show this. It's all completely declarative, and it starts with Argo workflow. And then if you go down, you have you're running it on SockShop, and then you're talking about experiments, right? So chaos experiments, you put it in. So if you see in real world example, this is, I have got 800 operations per second, orders per second. It's going on, and these red lines are nothing but chaos, right? So I go introduce some memory hog or CPU hog into various stuff, and then being able to see that. As you can see, whenever there is some chaos introduced, the performance went down, right, or the latency shot up, but it may be still within the range of threshold. When CPU goes to 90% hog, your orders went down from 1.5K to whatever, 1.37K. It is still okay, but it didn't stop, right? So that's a good one. I'm in control of this my service if such a chaos happens. So this is a very simple example. Use GitOps and chaos workflows to take it really, really deep, right? So that's one of my recommendations. Get started, and then you can you can definitely see some results. So that's all I have. Use Litmus, Flux, and Argo to manage chaos before and after upgrades. And Captain is another project where you can have quality gates. They provide a very nicely configurable quality gates where you can make a decision. Now, if your service is operating at 70% or whatever, your tests are operating, it's a gate check, right? And together, all of these projects, you will be able to be in control of what can go wrong, and if it really goes wrong, is your service is really good or not, right? So resilient or not. So that's all, folks. Follow us and take advantage of all the great work that community is doing. Thank you.
Thank you, Uma. We have a couple of questions.
Sure.
Yeah. What is the process maturity and prerequisite before we even attempt chaos engineering?
Yes. So it's a good question. It's about really you have to start, right? The earlier you start, the better it is. Process maturity, we're saying, chaos first is the principle that everybody is following. Don't be afraid of it. Start with your right away at the developer level. You have got a YAML declarative way to introduce chaos. So you deploy your app right after you code and you break it and see what happens, right? So you can start right away in a small quantity. Yeah.
Okay. So is there any console to help visualize this chaos workflow in action?
Yes, very good question. We've been doing this chaos thing right from, I think, for about 24 months now. There is a feature in development right now called Litmus Portal. It's I talked about it. Yes, that one will give a complete visualization of Prometheus metrics around chaos, and you can generate reports, and observability is a very important piece of chaos engineering. So yeah, it's going to come out. The alpha is coming out next month or after that. Yeah.
Okay. Okay. Last question. A quick general one. Why do you think GitOps might be a next big thing for DevOps, or is it a part of DevOps, or do you see a key differentiator among the two approaches?
DevOps is a practice, right? So it's an umbrella, right? So GitOps is it's more developer friendly. People are used to managing their code with a lot of collaboration controls, and people have started using that accepted practice into managing configurations, right? So there are many other operations are coming out under DevOps umbrella. So if you are on if you are following DevOps principles, then Kubernetes is a thing that you need. Even before Kubernetes, you are having DevOps. Now you move to Kubernetes because you have that. You can easily follow GitOps because there are tools available. Yeah, GitOps is the next big thing because it lets you sleep. You can use this methodology, these tools to orchestrate big things in a seamless way, right? So everything is, for example, Litmus portal, right? So the complex chaos workflows are going to be executed automatically using GitOps in the backend, right? So it's already in well accepted stream of thought.
Okay. Thank you, Uma, for
Good
walking
question.
us through Kubernetes adoption for right reasons. Well, I think ITs can handle configuration management and deployment because GitOps brings the development workflow closer to developers. So amazing session. Thank you, Uma, once again.
All right. Thank you, guys.
Thank you. With that, you can just hand over to host as to Vinay Agarwal.
Vinay Agarwal. Okay.